Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many 5-digit zip codes are possible if the digits cannot repeat or cannot be repeated and the last 2 digits are even? For this type of situation, let's use the fundamental counting principle by looking into the possible ways we could have or each placement of the zip code. Now this is a 5-digit zip code, very different from the Philippine zip codes, which are actually a 4-digit zip code, but this is an example that might be useful in similar situations. Take note, we have a 5-digit zip code, so 1, 2, 3, 4, and 5. However, we cannot apply here, or we cannot use digits for all the placements, because the first restriction is that the digits cannot repeat. In short, if we are able to use here, let's say, the digit of 1, and we have here 10 possible digits to be used, for the next digit or for the next placement, 1 can no longer be used. In short, the next would be lesser than 10. Now, aside from that restriction, we also have concerns for our last 2 digits, as these 2 digits here should be even. Now, let's talk about where do we target this first. To talk about to start, let's have these 2 last digits here. Why do we start with these 2? It's because it's very clear that for the last 2 digits, we will be using even numbers. And if we are to use them, they are to no longer to repeat for the first 3 digits. Because if you will start here, it will be very difficult for you to identify the remaining digits here. Okay? Because in the previous situation, where digits cannot repeat, we use this process 10, 9, and 8. That would mean that the digit used for the first digit can no longer be used for the second, and that the first 2 can no longer be used for the third. Hence, we have 10, 9, 8. But you cannot say here 5 for even if you're thinking about the last 2 digits will be even, because there are only 5 even numbers if we are going to consider generally 0 as even, because if 0 has been used here or 2 has been used here, this should not be 5. This is 4. But if odd numbers are used for the first 3, this can be 5. There are many possible situations for the 4th digit and the 5th if we are going to start with the first digit. Again, we will start with this digit here. So generally, we are considering 0 as an even number. Okay? Let's just use that because that's a commonly used identification. So that would mean for this placement, we have 5 digits. Okay? So we have 5 digits that are possible here: 0, 2, 4, 6, and 8. Now for the 5th digit, it should also be even. Once you've used 0, 2, 4, 6, 8 here, it can no longer be used for the next because digits cannot repeat. Hence, we only have 4 possible digits here. Now, with this already in mind, we can now use that idea in looking into the possible numbers that can be used, or number of digits that can be used for the first digit here. It's no longer 10 as what we have used previously, because we already used, say for example, if we use 2 here, that means again 2 can no longer be used for the last, so there will only be 4. Let's say we used 6 here. 2 and 6 cannot be repeated for the first digit. Hence, this is no longer 10. This should only be 10 minus the 2 digits or 2 even digits already used here. So we already have 8 digits here. Because if you were able to use already even numbers or even digits here, automatically you are left with the 3 other even digits and the 5 odd digits. Okay? Now for the next digit, it will now be connected to the first digit. Since you have only 8 digits here, as mentioned earlier, if you use 2 here, and if you used 6, what if you used here 1? These 3 digits can no longer be used for the second placement. Hence, we'll have here 7. And if we used here, let's say 9, this 4 can no longer be used for the third. Hence, you already have 6. So these are now the possible number of digits that can be used for the 5-digit zip codes with these conditions. Now, removing this in your mind, we are going to use here the idea of the fundamental counting principle. Hence, we'll be multiplying all of this, because for our fundamental counting principle, we're only going to multiply the number of possibilities for each placement. So with this, we are going to have 8 times 7 times 6 times 5 times 4. You will have a result of 6,720 possibilities. So this is the total number of possibilities for any 5-digit zip codes where digits cannot repeat and the last 2 digits are strictly even numbers. So this is for Count It In. Talking about getting the luck of the draw. For all in, subscribe now.